Hi everyone, in this video we're going to discuss about the divisibility. What is divisibility? In mathematics, divisibility refers to a number's quality of being evenly divided by any numbers without any remainder left over. It means that every number that we're going to divide another number, it should be divided equally and there is no remainder left over. Example, 4 is divisible by 12 and that is 3. Another one, 3 is divisible by 9 and that is 3. Those examples are example of divisibility. Now let's try an example that does not be divisible. First is 4 is divisible by 18. This example have a remainder and that is 2. Another one, 3 is divisible by 7. So in this example have a remainder and that is 1. So those examples are not a divisible.
Now let's have the notation for divisibility. If an integer a divides a second integer b without producing a remainder, then we say a divides b. Likewise, if an integer a does not divide evenly into a second integer b, then we say that a does not divide b. In other words, if a and b are integers, we say that a divides b if there is a positive integer c such that ac is equals to b. This is to say that a is a factor or divisor of b and that b is a multiple of a. A divides b if and only there is a c, where ac is equals to b, where a and b is an element of an integer and c is an element of positive integer. For example, let's determine whether 5 divides 15 and whether 5 divides 21. As we can see, 5 divides 15 seeing as 15 is a multiple of 5, but 5 does not divide 21 evenly as 21 divided 5 is not a positive integer. So as what I have discussed earlier, dapat si C is positive integers.
Now let's discuss the some properties of divisibility. First, if a is divisible by b, then for any integers x, a is divisible by b times x. Example, 3 is divisible by 9, and that is 3. Now let's apply the property. Let's assume that x is equal to 2. So, 3 is divisible by 9 times 2. 9 times 2 is equal to 18. So, 3 is divisible by 18, and that is 6. Now, let's assume that x is equal to 3. So, 3 is divisible by 9 times 3. 9 times 3 is 27. So, 3 is divisible by 27, and that is 9. Now, let's move on to another property. If a is divisible by b and b is divisible by c, then a is divisible by c. Example, 3 is divisible by 9, and that is 3. So, 3 is divisible by 3, and that is 1. Now, let's move on to another property, which is if a is divisible by b and a is divisible by c, then a is divisible by b times x plus c times y for any x and y is a real number of c. Example, 3 is divisible by 9 and that is 3. And 3 is divisible by 3 and that is 1. So now let's assume that x and y is equal to 2. So 3 is divisible by 9 times 2 plus 3 times 2. Then 3 times 2 is 6. 9 times 2 is 18. 18 plus 6 is 24. So 3 is divisible by 24 and that is 8. Now let's move on to the last property of divisibility, which is if a is divisible by b and b is divisible by c, then a is divisible by b plus c. Example, 3 is divisible by 9 and that is 3. 3 is divisible by 3 and that is 1. So now 9 plus 3 is equal to 12. So 3 is divisible by 12 and that is 4.
In continuation of the topic of divisibility, let's have a divisibility rules. What is divisibility rules? It is a set of rules that allows you to quickly determine if a given number is divisible by another number without using a long division. Let's start with divisibility by 2. A number is divisible by 2 if its unit digit is even and the last digit are 0, 2, 4, 6, and 8. For example, 456 is divisible by 2 because because its unit digit is 6. It is an even. So next is divisibility by 3. A number is divisible by 3 if the sum of its digit is divisible by 3. For example, 891 is divisible by 3 because 8 plus 9 plus 1 equals 18, and 18 is divisible by 3. Next is divisibility by 4. A number is divisible by 4 if the number formed by its last two digits is divisible by 4. For example, 1236 is divisible by 4 because the last two digits is 36 is divisible by 4. Next is divisibility by 5. A number is divisible by 5 if its unit digit is either 0 or 5. Example, 2350 is divisible by 5 because its last digit is 0. Next is divisibility by 6. A number is divisible by 6 if it is divisible by both 2 and 3. Example, 312 is divisible by 6 because it is divisible by both 2 and 3. Next is divisibility by 7. To find out if a number is divisible by 7, take the last digit, double it, and subtract it from the rest of the number. If you get an answer divisible by 7, then the original number is divisible by 7. Example, 3192. The last digit is 2, double. 2 times 2 is 4, then subtract from 319 equals 315, then 315 is divisible by 7. Next is divisibility by 8. A number is divisible by 8 if the number formed its last three digits is divisible by 8. Example, 5824 is divisible by 8 because the last three digits is 8 to 4 is divisible by 8. Next is divisibility by 9. A number is divisible by 9 if the sum of its digit is divisible by 9. Example, 1953 is divisible by 9 because 1 plus 9 plus 5 plus 3 equals 18, and 18 is divisible by 9. Next, divisibility by 10. A number is divisible by 10 if it ends or the last digit is 0. Example, 7540 is divisible by 10 because it ends in 0 or the last digit is. Next is divisibility by 11. The sum of odd number digits minus the sum of even number digits is divisible by 11. Example, 12,332,848. Next, the odd numbers are 1 plus 3 plus 2 plus 4 equals 10. The even numbers are 2 plus 3 plus 8 plus 8 equals 21. Then 21 minus 10 equals 11. 11 is divisible by 11. Next is divisibility by 12. Number is divisible by 12 if it is divisible by both 3 and 4. Example, 2208 is divisible by 12 because it is divisible by both 3 and 4. Next is divisibility by 13. First is delete the last digit from the number, then subtract 9 times the deleted digit from the remaining number. If the difference is divisible by 13, then so this is the original number. Example, 715. The last digit is 5, then 71 minus 5 until 9 times equals 26. 26 is divisible by 13, 5. Next, divisibility by 16. A number is divisible by 16 if the number formed by last 4 digits is divisible by 16. Example, 18,736 is divisible by 16 because the last 4 digits are 8736 is divisible by 16.
Now, what is division algorithm? So, dito papasok yung division algorithm. Kasi, yung divisibility, focus only na dapat may divisibility, dapat evenly, walang remainder na nangyayari. So, dito sa division algorithm, mahanap natin yung quotient as well as the remainder. Now, what is division algorithm? Euclid's division lemma states that for any two positive integers a and b, there exist two unique whole numbers q and r such that a is equals to b times q plus r, or a is equals to b times r quotient plus remainder, where r is greater than or equal to 0 and less than b, where a is the dividend, b as divisor, q is quotient, and r is remainder. And getting the remainder, actually we can use the modulo, but let us focus on the basic operations. Now, for example, what are the quotient and remainder when 19 is divided by 7? So we have 7 divided 19. Here we use long division to get the remainder. So 7 divides 19, we have 2, and 2 times 7, we have 14. 19 minus 14 is 5. So our quotient is 2 and remainder is 5. Now substitute it to our formula, we have 19 equals 7 times 2 plus 5. So now, how about we have a negative integer a and positive integer b? Kasi it has been discussed earlier na a and b can be an element of integer, so pwede negative. Now, how can we get the quotient and remainder? So we have here the formula. So r is equals to a minus b times q, or our quotient. So let's have an example. So 7 divides negative 22. So if we're going to calculate it, we have negative 3.1428, right? Now, if the result is not an integer, round it down to the next smaller integer, so our quotient would be negative 4. Now, let's substitute. So, this is the formula for our remainder. So, we have r is equals to negative 22 minus 7 times our quotient, which is negative 4. So, our remainder is 6. Now, going back to our for division lemma, so we have negative 22 is equals to 7 times negative 4, which is our quotient, plus 6, our remainder. And that's it.
For the continuation, I will discuss to you the greatest common divisor, or the GCD. But before that, let me define first what is GCD and the methods to be used and how to find it. So, GCD, it is the largest positive integers that divides both A and B. So meaning, si GCD daw, siya ang pinakadako nga numbers na pwede ma-divide sa duha o tulo ka given numbers. It is denoted by GCD A, B. So, there are several methods to be used on how to find it. We have the listing method, the prime factorizations method, the Euclidean algorithm, or the Euclid's division algorithm. So, I have here an example on how to find the GCD using the listing method. The GCD of 15 and 10. So, the first step to do is to make a list all the factors of the given two numbers. So, kuhaan sa nato ang factors na 15. So, sa ba ang mga factors na 15? So, we have 1 and 15. And also, we have 3 and 5. So, mga factors na mag-result sa 15 without remainders. So, next is, kuhaan na to ang mga factors ni 10. So, we have 1 and 10. And also, we have 2 and 5. So, as we can see, nasa like common factors nga 1 and 5. But we focus on the greatest common divisor. So, the GCD of 15 and 10 is 5. So, this method is only applicable in list numbers. So, the other method to be used in finding the GCD is the prime factorizations method. So, it is the method in finding all the prime numbers that multiply to form a number. So, when we say prime, it is a whole number that greater than 1 that has no other factors except 1 and itself. So, some example of prime numbers is we have 2, we have also 3, 5, 7, 11, 13, and many more. So, I have here an example on how to find the GCD using the prime factorizations method. So, we have the GCD of 48 and 32. So, the first step to do is kuhaan muna nimo ang prime factorizations ni 48. Mga to, prime factorizations ang 48. Nungita ang prime numbers na pwede natin i-divide ang 48 without remainders. So, itry natin sa 2. 48 divide 2 is equals to 24. Divide natin ulit by 2. 24 divide 2 is equals to 12. Divide natin ulit by 2. 12 divide 2 is equals to 6. And 6 divide 2 is equals to 3. So, these are the prime numbers na kung multiply na ito together, kaya mag-result siya 48. So, list natin. 2 times 2 times 2 times 2 times 3. So next is kung ano po na ito ang prime factorizations ng 32. Same sa paglibad kay 48, makita na sa prime numbers na pwede nato i-divide ng 32 na wala siya remainders. So, try nato ulit si 2. 32 divide 2 is equals to 16. Then 16 divide 2 is equals to 8. Then 8 divided by 2 is equals to 4. Then 4 divided 2 is equals to 2. This natin, 2 times 2 times 2 times 2 times 8. So, after that, factors that two numbers that have in common. So, they have common 2 times 2 times 2 times 2. So, 3, wala naman siya parehas ng 32. So, kanina. Then, i-multiply na to together. 2 times 2 is equals to 4. Then 4 times 2 is equals to 8. Then 8 times 2 is equal to 16. So, therefore, the GCD of 48 and 32 is equal to 16. The other method to be used in how to find the greatest common divisor is the Euclidean algorithm. So Euclidean algorithm, it is the technique in quickly finding the GCD of the two integers. Our condition 1, if B divides A, then the GCD of A and B is equals to B. The condition 2, if B not divides A, then we do the following. We have the formula of the Euclidean algorithm. In the previous discussion, we already know that the division algorithm is the foundation or the recursion of the Euclidean algorithm. I have here an example on how to find the GCD using the Euclidean algorithm. We have the GCD of 98 and 70. So we have the formula of A is equal to B times Q plus R. So our A here is the 98. Then the 70 is our B. So do that long division. 98 divided 70 is equal to 1. Then we have the remainder 20. This is our remainder and this is our quotient. So we have the quotient of 1. We add that to say remainder na 20. After that, tayo na po sa 70, yung A. Then this is our B, the remainder. So do again the long division. So remainder, this is our quotient. So we have the quotient of 2 plus our remainder 14. So again, kanina po din mo ang A. Then kanina pa ito, remainder mo na itong B. So we have 28 divided by 40. 28 divided by 40 is equal to 2. Then 2 times 40 is equal to 20. So we have the quotient of 2. So wala naman tayo remainder. So itong babaw atong 0, a remainder, mo-only siya atong GCD. So we stop here because of the condition of 1. So our GCD of 98 and 70 is equal to 40.
Now let's proceed to our example. First is find the GCD of 70 and 98. Ang una na itong buhaton is punta na ito ang value ni A o ni B. So ang value ni A ay mauna siya ang pinakadakong na value sa given na to. So sa man ang pinakadakong na value, di ba 98? So therefore, ang atong A karon kay si 98. While ang atong B kay si 70. Then after na-apply na ito itong formula. A is equal to BQ plus R. So sa A na ito kay 98, substitute lang na ito. Then ang atong B kay C 70, substitute lang. Then karon naman ta kabalo sa Q of R. So ato siyang pangitaon. Saan man siya pagpangita? So kini si 98 kay divide nato ni siya kay 70. So ang iyang result is 1.4. Therefore, ang kanang whole number diha mao na siya karon ang atong Q or quotient. So si 1. Then pagpangita na pud sa R kay katong whole number or quotient nato, i-minus lang nato to siya sa result ni 98 divided by 70, which is 1.4. So, 1.4 minus 1 is equal to 0.4. Then, kasi 0.4, kaya ato na siya i-times kay 70. which is katong number nga atong i-divide kay 98 para makuha nato sa remainder. So 0.4 times 70 is equal to 28. Therefore, ang ato karong remainder kay si 28. 98 is equal to 70 times 1 plus 28. Kaya wala pa man na 0 ang atong remainder. Ang atong sunod nga buhaton karon kini si B diri A, which is 70. Mao na siya ang atong A. While si 28 diri A or atong remainder, mao na siya ang atong bagong B. So, gamit ang formula A is equal to BQ plus R, substitute lang nato. So, 70 is equal to 28. Then, saan mo pagkuha si quotient karon? Same process ganiha. 70 divided by 28 is equal to 2.5. So, minus nato si whole number. Then, kanang decimal dira ato na siya i-times kay B, which is 28. So, therefore, ang iyang remainder kay 14. So, kay wala pa man siya na 0, ang atong sunod nga buhaton kay same process ganiha. Si 28, mo na siya itong A, while si 14, mo na siya itong B. So, 28 divided by 14 is equal to 2, then 0 na dayon. So, kay na 0 naman sa remainder, kung unsa ang second to the last remainder, maon na ang GCD. So, therefore, the GCD of 7098 is 14.
We will talk about extended Euclidean algorithm. Pero kung na mo knowledge about Euclidean algorithm, dali na lang ni sabton ang extended Euclidean algorithm. So, let's start. EEA or extended Euclidean algorithm builds on top of the basic Euclidean algorithm, or it is an extension to the Euclidean algorithm. So, sa gikaingon na ko kung na mo knowledge sa Euclidean algorithm, sayo na lang siya sabton. So, di ba ang sa Euclidean algorithm is pangitaon na nato si GCD. So, kani si extended Euclidean algorithm, pangitaon ka po niya si GCD. Pero, apilon na niya ang pangita si X and Y. So, mo siya. It also finds integer sa gikagunggan ako, X and Y. So, pero ang isa sa ila is negative. That usually satisfy Besought identity. So, si Besought identity guarantees the existence of X and Y. So, let's have an example. Kaya nakuha naman nato si GCD, which is 14. Muadto na takang extended Euclidean algorithm. Pero, anong usahay nga, maglisod ta og sabot kung mudiritso ta kang extended Euclidean algorithm. So, nga itong himoon, mag-solve ta for the remainder. Now, presan, illustrate ako ha. So, 98 is equals to 70 times 1 plus 28. So, himoon na to siya into 28 equals to 98 times 1 plus 70 times negative 1. So, inaniun na to siya daan kay para inigado na nato kang extended Euclidean algorithm, dali na lang siya. So, mo na lang iya atong tanawon diritso. So, kang 70 equals to 28 times 2 plus 14. So, mahimo na siyang 14 equals to 70 times 1 plus 28 times negative 2. So, after ana, kuwaon na to si atong last remainder solution, which is tong si 14 equals to 70 times 1 plus 28 times negative 2. So, bali mo to siya ang unahon na tong sulat. Mo to ang atong unang basihan para makuha na to katong value ni X and Y. We will be using now the extended Euclidean algorithm. Diba sa last remainder solution is, moment to si 14 is equals to 70 times 1 plus 28 times negative 2. So, mo to siya ang atong unang ibutang. So, after ana, i-substitute nato tong value ni 28. Okay, ang sunod ni 14 is si 28 man. So, mo to siya ang atoang i-substitute. So, mahimo siyang 70 times 1 plus 98 plus 70 times negative 1 man katong partner ni 28 nga negative 2. Then, after ana, i-simplify nato sila. So, mahimo siyang 70 times 1 plus 98 times negative 2 plus 70 times 2. Then, after ana, i-combine like terms nato. So, ang 70 kay count as 1 naman na siya. I-combine nato siya kay 70 times 2. So, mo siyang nahimo siyang 70 times 3 plus 98 times negative 2. And after ana, humana. It's done. So, nakuha na nato ang value ni X and Y. So, diba sa ikaingon ako sa katong pag-explain ako about kang extended Euclidean algorithm is ang isa sa ilaha sa kay X and Y is negative. So, mo to siya, ang value ni X is negative 2 ug ang value ni Y is 3. So, tungod kay nag-una si 70 ug ulay si 98, doesn't mean nga si 70 na ang si X ug si 98 na ang si Y. No. ang ato gapong sundon is katong kung kisa tong nauna katugon sa finding GCD. So di ba? GCD 98 and 70. So si 98 man to si x, di ba? So tong sa Diophantine equation, di ba? 98x plus 70y. So mao gahapon to siya ang atong sundon.
Let's moving on to the example of the EEA, or that is called an extended Euclidean algorithm. So I cite example here. First is the 7,544 and 115. Let A is equal to 7,544 is our dividend. B is equal to 115 is our divisor. To get the EEA, or the extended Euclidean algorithm, we have two steps that we need to follow. First is use Euclidean algorithm to find the GCD. We all know naman kung unsaon pag-find, unsaon na to pag-calculate ang GCD. Kaya natakil naman siya in previous na to nga discussion. Sige, 7,544 divide 115, the quotient is 65 point something, but ang ato lang kwaon is ang iyang whole number. And then, ang atong remainder is 69. 115 divides 69, the quotient is 1, and the remainder is 46. 69 is equal to 46, the quotient is 1, the remainder is 23. 46 divide 23, the quotient is 2, and our remainder is 0. So, our GCD na karon kay 23. So, extended Euclidean algorithm is known as the backward substitution of Euclidean algorithm because it gives two integers x and y such that ax plus by is equal to our GCD. So, ang EEA, ang goal nato diri is ang atong x and y nga unsa nga values, kung atong i-times atong a ug b is dapat same ang answer sa atong GCD. So, let's proceed to the step 2. Use Euclidean algorithm to write 2 as a linear combination of 7,544 and 115. So, our GCD is 23. So, kung pag-calculate na to sa diri adapit, dapat mag-result po siya og 23. Sige. 23 is equal to 69 minus 46 times 1. Kaya atong remainder is 23. Ang 23 naglayo man siya sa 69 o 46. Next, i-change na to ang sign. May mo siyang 69 plus 46 times negative 1. Sunod, 69 plus the bracket of 115 minus 69 times 1 times negative 1. And then, change siya pala to ang sign. 69 bring down plus 115 plus 69 times negative 1 times negative 1. So the result is 69 because 69 negative 1 times negative 1 positive 1 plus 1 is 2. So 2 and then copy ang 115 then negative 1. Tanaw na sab nato ang remainder. So ang taas at 36 kay 78 man. So may mo siyang 7,544 minus 115 times 65 times 2 plus 115 times negative 1. So change na po natong sign. 7,544 plus 115 times negative 65 times 2 plus 115 times negative 1. So the result is 7,544 times 2 plus 115 times negative 131. Nahimo siyang 131 because negative 65 times 2 is negative 130 plus negative 1 is siyang 131. So 7,544 times 2 plus 115 times negative 131, the result is 23. So, ang atong solution sa number 1 kay tama because our GCD o atong pag-calculate is same ang answer.
So, hello everyone. Since we are done with other topics that was discussed with my co-future educators, let us move on with another topic, which is the linear Diophantine equation. So let us start with its history. So linear Diophantine equation is named after Diophantus of Alexandria, who lived in the 3rd century AD. So Diophantus is also referred as the father of algebra tungod sa iyang mga algebraic works, and included na po dira ang linear Diophantine equation. So let us continue with a question. So what is a linear Diophantine equation? So LDE is an equation in the form ax plus by is equal to c, where ang A, B, and C are all integers and ang X and Y are kaning variables. So what is our goal in solving LDE? So our goal in solving LDE is to find an integer solution sa atong X and Y nga makasatisfy sa ato ang equation. So in solving LDE, we have 6 steps nga pwede nato sundon. The first step is to find the GCD using the Euclidean algorithm, and then the second step is to ensure that our GCD is divisible by our C, which is an integer, and then our third step is to apply our extended Euclidean algorithm, and then our fourth step is to identify our U and V in the equation. Our fifth step is to identify our X sub O and Y sub O. And then our last step is to identify our X and Y. And then to further explain this LDE, we can have an example. So let's have an equation to solve. It is 8x plus 12y equals 20. So do you remember our first and third step? It is the first step is to find our GCD using the Euclidean algorithm. The second step is to make sure that our D is divisible by our C. The third step is to apply our EAE. So since I already know that you have a background in this, in solving on this, because of the previous topics or discussion that was already done, I will make sure to pause the video and I will let you try to solve this by yourself. So thank you for pausing the video and trying to solve now. So let us check if we arrive with the same answer. So in finding our GCD, this is our new equation. It is 12 is equal to 8 multiplied by 1 plus 4, and then 8 is equal to 4 multiplied by 2 plus 0. So we easily identify that our 4 is our GCD. And then our second step is to make sure that our 4 is divisible by our C, which is 20. So 4 is divisible by 20 because 20 divided 4 is equal to 5. So we can continue to our third step, which is to apply our extended Euclidean algorithm. And then our equation now is 4 is equal to 8 multiplied by negative 1 plus 12 multiplied by 1. So our fourth step is to identify our U and V. And then in the equation ax plus by, our u and v is the x and y. So our u now is the negative 1, and then our v is the positive 1. So in step 5, we will identify what is our x sub o and y sub o. So by finding our x sub o, we will multiply our u by our c, which is an integer, divided by our d. So our u is negative 1 multiplied by our c, which is 20, divided by our GCD, which is 4, is equal to negative 5. Now in finding our y sub o, v is multiplied by our c, which is 20, and then our v is positive 1, and then negative by divided by our GCD, which is 4, and then we arrive at the answer positive 5. So let's move on in our last and sixth steps, which is in finding our x and y. So in finding our x, we have a formula x sub o plus b over d multiplied by some integer k. So since our x sub o is equal to negative 5 plus our b, which is the 12, and then divided by our GCD, which is 4, multiplied by some integer k, we arrive at the answer negative 5 plus 3k. And then in finding our y, we have a formula y sub o minus a over d multiplied by some integer k. So since our y sub o is equal to 5 minus our a, which is 8, divided by our GCD, which is 4, multiplied by some integer k, we arrive at the answer 5 minus 2k. So therefore the integer solution of our x and y is x is equal to negative 5 plus 3k, y is equal to 5 minus 2k. So thank you for participating and listening, and I will leave you an example for you to practice and to solve on your own.
So let's have some example on how to get the linear differential equation. We have here the GCD of 1027 and 712 is equal to 1. So first step, we need to get the GCD of 1027 and 712. So 1027 is equal to 712 times 1 plus 315. Then 712 is equal to 315 times 2 plus 82. And 315 is equal to 82 times 3 plus 69. And 82 equals 69 times 1 plus 13. Then 69 is equal to 13 times 5 plus 4. And 13 is equal to 4 times 3 plus 1. Then lastly, 4 is equal to 1 times 4 plus 0. Therefore, the GCD of 1027 and 712 is equal to 1. And 1 divides 1, so it has an integer solution because D divides C. And for our step 3, we need to use the extended Euclidean algorithm. And I assume that you knew already how to solve using EA. So let's proceed to the step 4, which is the answer for our step 3. So our U here is equal to negative 165 and the V is equal to 238. So let's proceed to the step 5. Formula of step 5 is x sub O is equal to U times C over D. And for our Y is Y sub 0 is equal to V times C over D. So let's solve for the x sub 0 or x sub O. So for our x sub O is equal to negative 165 times 1 over 1. So our answer for here is negative 165. And for our y sub 0 or y sub O is equal to 238 times 1 over 1. So our answer here is 238. And lastly, for our step 6, the formula that we need to use here is x is equal to x sub 0 plus b divides d times k. And for our y is equal to y sub 0 minus a over d times k. Let's solve for our x. X is equal to negative 165 plus 712 over 1 times k. And so for our answer here is x is equal to negative 165 plus 712 k. And for our y is equal to 238 minus 1027 over 1 times k. So our answer here is 238 minus 1027 k. Therefore, the general solution of the given equation is negative 165 plus 712k and 238 minus 1027k, where k is an element of z.
So, to apply what we learned from the previous discussions, let's have a worded problem example. An oil company has a contract to deliver 110,000 liters of gasoline. Their tankers can carry 2,500 liters and they can attach on trailer carrying 2,200 liters of each tanker. All the tankers and trailers must be completely full on this contract. Otherwise, the gas would slosh around too much when going over some rough roads. Find the least number of tankers required to fulfill the contract and find the general solution using linear Diophantine. The first thing that we will do is to know what is the given from the problem. So let X be the tankers and let Y be the trailers. So our equation now is 2,500X plus 2,200Y is equal to 110,000. So let's find the GCD of 2,500 and 2,200. So 2,500 divided by 2,200, ang iyang quotient is 1 plus the remainder is 300. Then 2,200 divided by 300, the quotient is 7 plus the remainder is 100. 300 divided by 100, ang quotient is 300. Then plus, so wala naman siya remainder. Therefore, ang iyang GCD is 100. And then to apply to the problem, therefore, the least number of tankers required is 100 each trailer to fulfill the contract. So now let's find the general solution to the problem using linear Diophantine. Since 100 divides 110,000, the linear equation has a solution. So using the extended Euclidean algorithm, 100 is equal to 2,200 plus 300 multiplied negative 7. 100 is equal to 2,200 plus
2,500 plus 2,200 times negative 1, and then i-multiply mo na siya sa negative 7. Yan, 100 is equal to 2,200 times 1 plus 2,500 times 7 plus 2,200 times 7. Then, atoa siyang i-combine like terms. So, 100 is equal to 2,500 times negative 7 plus 2,200 times 8. So, ang atoang u is negative 7, which is ang x, and then ang v is equal to 8, which is ang y. So, we have the formula to find the x sub 0. Then, x sub 0 is equal to u times c divided by d. Then, ato ang i-substitute. So, x sub 0 is equal to negative 770,000 divided by 100. So, ang ato ng x sub 0 now is negative 7,700. Let's proceed to find the y sub 0. Y sub 0 is equal to v times c over d. Y sub 0 is equal to 8 times 110,000 over 100. Y sub 0 is equal to 880,000 divided by 100. So our y sub 0 is equal to 8,800. Then to find the general solution, x is equal to x sub 0 plus b over d times k. So our x sub 0 is equal to negative 7,700 plus rb is 2,200 over our GCD 100 multiplied by k. So our x now is x is equal to negative 7,700 plus 22k. So to find y is equal to y sub 0 minus a over d times k. So our y sub 0 is equal to 8,800 minus our a, 2,500 over our GCD, which is 100 multiplied by k. So our y is equal to 8,800 minus 25k. Therefore, the general solution of the given equation is negative 7,700 plus 22k and 8,800 minus 25k.
The concepts of greatest common divisor or GCD and divisibility have significant practical implication in real life. They help us solve problems, make calculations, and understand patterns and relationships in various domains. GCD allows us to find the largest common factor between two or more numbers. This is valuable in simplifying fractions, optimizing computations, and solving linear Diophantine equations. In everyday life, GCD can be applied to tasks like scheduling events, converting measurements, and creating harmonies and music. It provides a foundation for efficient algorithms in computer science and plays a crucial role in cryptography and modular arithmetic. Divisibility, on the other hand, helps us determine if one number divides evenly into another. It aids in performing operations like long division, simplifying fractions, and checking for patterns and regularities and sequences. Divisibility rules are useful in programming, enabling us to validate inputs, iterate over numbers efficiently, and perform specific actions based on divisibility properties. Divisibility concepts also came into play when dealing with measurements, ratios, and time intervals. In summary, GCD and divisibility have practical application in a wide range of fields, including mathematics, engineering, computer science, scheduling, measurements, music, and more. They allow us to solve problems, optimize processes, and understand the underlying mathematical principle in our everyday life.